Hey, today on Ask the Trainer, I got a new question for you. This comes from Anthony in Boston. Before I jump into the question, shout out to Anthony. This is his second submitted question to Ask the Trainer. It's great to see you are engaged, you're inquisitive, you want to learn more. So thanks. Keep those questions coming. His question today is, can a BaseStation 3200 be used to run Christmas lights, and how does that work? Yes, they can be, and it actually isn't particularly hard. There's a few pieces of hardware you need, and they're going to depend if you're running two-wire or conventional wire, and we'll look at both today. Let's take a look at the hardware you need. So if we're going to connect to a two-wire system, we obviously need a two-wire path connection, so I've got that going here. The other parts that I have is a Dayton socket, and this is model number 5X852N, and then a Dayton relay, and this relay is model number 5X826N. So these two pieces fit together. They'll just snap together and we'll connect them like that. Right? There's nothing particularly unique about this Dayton relay. It's just that we have tested all of this with the Dayton relay and our instructions to do this. You're welcome to use your own relay if you happen to have one, or if you don't like this one or they're not accessible. You're just going to have to figure a few things out on your own. Our instructions refer to the Dayton relay. You're going to need a 5201 single zone bicoder. You may already have that. And that's pretty much all you need. And then after that, you're going to have your high volt circuit that you're going to connect up. So that's what we need for the two-wire path. Now, if you have a conventional wire system, you need actually even less equipment. We don't need the bicoder because the bicoder is built into the board. So you're going to need an open zone on your board. So you need one spare zone available on this. You're going to need wiring, a common and a station wire running to the Dayton relays and Dayton socket, the exact same relay socket, and then the high volt on this side. So that's all we need for the conventional. So what does it look like to wire it up? Let's take a look at that. So here's what the wiring looks like. We've got our two-wire path coming in, the splices going to our 5201 single zone bicoder. Notice my splices are not waterproof. If you're in a waterproof enclosure, that's fine. If it's indoors, that's fine. But these were really, I'm only using these for testing. So generally don't use these. I've got the bicoder. The output of the bicoder is going to the two terminals of the relay socket, and that's going to activate the socket, activate the relay actually. And then what we have is the high volt coming in and high volt coming out. So this stops at the relay, and when the relay activates it, it allows it to run through. So how does this work in actual practice? A signal comes in from the controller. It's telling it a program is telling it to run or some other start condition. It acknowledges the bicoder. The bicoder is going to put 24 to 34 volts out to the relay, activate the relay, and allow the high voltage to pass through the relay out to this and out to our circuit, and that turns on our lights. So this is what it looks like on a conventional wire system. We've got our powered bicoder with our wires running out to our individual zones. And I said we need a spare zone, so we've got that connected up to this terminal. That runs out to the relay block. I've got the common, which runs out to the relay block. Essentially, we're just using one of the zone terminals to run the relay, and the high volt in and the high volt out. So in this one, when the power bicoder sends out the signal, it activates 24 volts over this wire path, allows the 110 to pass through, and now we have high volt out, which turns on our lights, and it runs its program the way it should. So I mentioned one of the things you need is a relay, and let's just back up and explain real briefly what a relay is if you're not familiar with them. A relay is an electronic switch. This is how we can use low voltage, usually 24 to 34 volts on one side, to safely switch a higher voltage, 110, 120, or higher. So this is a safe way of electronically running a switch with our controller or with any other device. I also mentioned that there's nothing particularly unique about this Dayton relay, only that we've tested with it. What is important on this relay is that it's rated for the right voltage and it's rated for the right amperage. So this particular relay can have a pretty high amperage rating, and it can run 220. So I was showing a white and a black running through there. Honestly, you only need to switch the hot side, so you could switch two hot legs if you're in electrical. The other thing I should have mentioned at the beginning is definitely want to get an electrician involved in this one, right? I know that contractors are always anxious to do everything themselves. Definitely a good idea to involve an electrical on the high voltage side. Low voltage is no big deal. You can handle that all yourself. There's no code requirements for that. High voltage, definitely involve a professional. Okay, so we've got our hardware installed, either conventional or two-wire. Let's talk about programming. So to do that, we need to go to Base Manager. So let's flip over to Base Manager. So I've got App Manager and specifically Base Manager open, and we can see my programs are already set up. I've already created a unique schedule. So let's open up schedule number 10, which is already named Christmas Lights. But I'm going to click Edit so we can make some changes here. Again, naming a program can be done from Base Manager. It carries out to the controller. Right now it is enabled, but during off season when I don't have lights, I'm going to disable this program, but leave it in there. I want it to run right now, so we're going to make sure it's enabled. I've got it set for just zone 92. That's the only zone that I want running because that's the only run that runs my relay, which connects to my high volt, which runs all of my Christmas lights. I'm leaving it in timed mode and set it for 360 minutes, which translates into what I think 6 hours. Okay. I'm leaving everything else alone. I'm having it run every day at 7 p.m. and I'm not messing with the water window. I'm leaving that alone. But two other things that I want to change that I think are important is this obey global conditions. I want to uncheck obey global conditions. Global conditions refers to mainly a rain sensor. So if it rains, it will shut down all of my zones. Well, I don't want that to happen. I want this particular relay and zone to keep running even though it's raining. So I'm going to ignore global conditions. The other thing I want to do is, since this is electrical and it is not hydraulic, it doesn't impact how many zones I can run. So I want to exclude this from total controller concurrency. Don't count this in how many zones. If I said I can only run 5 zones because of my mainline size, this has no bearing on that. Okay? Other than that, it's all good. So I can save that. So programming, relatively simple, though. Just pretty much those 2 changes would be the only things that I think are important. A couple other things that are kind of interesting about this, right? And this is why this is kind of exciting for me is we're talking about Christmas lights or Hanukkah lights or Kwanzaa lights, right? Whatever, holiday lights, but it could be something else. It could be a lighting program for overhead lights, security lights, tennis court lights. Okay. Well, it doesn't have to be lighting. It could be a fountain. It could be electronic door locks, right? It could be all these different things that are electrical, essentially with the use of this relay that allows me to use 24 volts or 34 volts to switch 110, 220, or higher voltages. I just would need a different relay to take those higher amperages and those higher draws. The other thing you get is now we've got mobile access, right? Now I have the ability to run those lights from my phone wherever I am. So how did we get all this information? How did I know how to do this? Let me show you where I got this information. On the Baseline Systems webpage, there is a file for turning electricity on and off with the program. So it tells you the materials you need, exactly what we talked about today, the steps. But then here's the one that you're really going to like, is we've got a wiring diagram. And this wiring diagram is based off of that Dayton relay. So I'll put a link for that in the notes. You'll be able to find that direct link right to that PDF. So my challenge to you today is figure out what else besides Christmas lights that you can run with your BaseStation 3200 or BaseStation 1000. Have a question for me? Click the link in the description and go to hydropoint.com/askthetrainer to submit your question.